Today you're going to look at what is a limiting reactant. How do you know what the limiting reactant of a reaction is? We're going to study the addition of HCl to sodium hydroxide. And if you notice, it always forms in a neutralization reactant, a salt, in this case sodium chloride, and water. You'll notice that everything across here is in a one-to-one stoichiometric relationship. So what does it mean to have something in excess or something that's limiting? If we look at these beakers, in the first beaker we have water and hydrogen ions and chloride ions because HCl, when it dissolves in water, totally dissociates. In the other container, you're going to have water, sodium ions, and hydroxide ions. This is a strong base, so the sodium and hydroxide dissociate. When they react, you're going to form water, sodium ions, and chloride ions because they stay dissociated. And if HCl is excess, there's extra HCl, you've just added a little bit of sodium hydroxide. All the sodium hydroxide reacts, but you have hydrogen ions and chloride ions in excess. They'll still be there. Now, what happens if sodium hydroxide is in excess and the HCl, the hydrochloric acid, is limiting? You start with the same two containers. And now in your final container, after you mix them, you're going to have water again. You're going to have sodium chloride in the form of sodium ions and chloride ions. But now the excess is going to be sodium and hydroxide ions. All the HCl, all the hydrochloric acid, has been neutralized. So any additional sodium hydroxide makes sodium hydroxide excess. All right, let's look at what's going to happen with the calculations. First off, remember the definition for molarity. Molarity, capital M, is moles per liter. Only use the uppercase M, not the lowercase, for molarity. Now, if you rearrange this equation, what you get is moles equals molarity times liters. Remember, molarity is mole per liter, so liter cancels out, leaving molarity. So the total moles of acid is going to be the volume of the acid times the molarity of the acid. The moles of base is going to be the volume of sodium hydroxide added times the molarity of the base. These two numbers you're going to read off the bottles. Once you get them. And they should be 4 significant figures. Okay? Then you're going to decide, after you've added 10 milliliters of sodium hydroxide to the 25 milliliters of hydrochloric acid, which one is limiting, which one is in excess, and what is the solution color. The solution color is going to come from phenolphthalein, Phenolphthalein is colorless in acid and red in base. So the solution will stay colorless right up until the point that it becomes basic. Okay? Then, after you add 35 milliliters of sodium hydroxide, how many moles of acid did you add? It's going to be volume of the acid times molarity of the acid, which won't change, will it? Because you had the same volume in both cases of the acid. But the moles of base is going to equal the volume of the base now added, and that's the total volume of the base. And again, decide which one is limiting and which one is in excess, just like you did before. Okay? So we're going to come down to the calculations. You're going to go into the Beyond Labs program. You're going to get from the storeroom the HCl and the molarity and mark down its molarity using every significant figure. Now, the next thing you're going to do is pipette 25 milliliters of HCl into a beaker. So how many moles are in that pipette? Molarity times volume of the acid. Now, one thing you have to remember, the volume is going to equal the milliliters times 1 liter is 1,000 milliliters. You have to convert milliliters to liters. Then you're going to calculate how many milliliters of sodium hydroxide to neutralize your base. Okay, to calculate this, the easiest way is to do molarity of acid times volume of acid equals molarity of the base times the volume of the base. Because at the point of neutralization, the moles of acid equals the moles of base. So you're going to rearrange this equation, and you'll say the volume of the base to neutralize, or to neutralize the acid is going to equal molarity times volume of the acid divided by molarity of the base. And here, because units are canceling, you can leave it milliliters. You do not have to change to liters. So now you're well on your way to doing the calculations you need to do. You're going to record the exact volume of the sodium hydroxide. That should be read to 0.01 milliliters. And you can read that carefully by clicking on the center of the burette, and then that should open up the window to be able to read your burette carefully. And remember, you always read the meniscus, the bottom part of the arch in the burette. And then you're going to go through and you're going to calculate the moles of sodium hydroxide you added. That's the same calculation you've already done. You're going to look at how many moles have actually reacted. Then how many moles are left unreacted? So that's going to be the total moles of HCl minus the moles of HCl reacted. And then you're going to calculate how many moles of water are produced. Remember, 1 mole of water to 1 mole of limiting reagent. You always have to use the limiting reagent for the calculations, but that's your mole ratio. And then you'll continue similar calculations. What's the volume on the burette? How many moles of sodium hydroxide? How many moles of acid? How many is there in excess? And the calculations will be the same all the way through, except on the third addition, sodium hydroxide should be in excess in HCl limiting. So you should be able to calculate these by following your steps of carefully thinking through what this calculation is.